Hi all, I am Shreya Anand, a data scientist with emerging technologies at Red Hat. Today, we are going to take a look at how to use Open Data Hub or ODH services to create an inference pipeline for a natural language processing model. ODH is a data and AI platform for the hybrid cloud that we use to run the NLP demo. All the tech used in this demo is open sourced and free for use and contribution through this AI COE OCS demo repository. The NLP solution is a part of the OS Climate Initiative that aims to develop software and predictive analytics to manage climate-related risks. You can find more information about the initiative in the description of the demo. We'll start by motivating the problem in brief and then move on to the technical aspects that involve setting up the environment, running the Jupyter notebooks, creating an automated pipeline, and saving the results in a SQL table, and finally visualizing it using a dashboard. All right, let's jump into it. So, reading a 50-page long PDF manually to find information is a cumbersome task. If you have thousands of such PDFs, then the automation part becomes necessary. The NLP model in this demo works precisely on this task. It takes PDF of climate reports from different companies and finds answers to questions that we're interested in. In the first part of the demo, we'll look at how to create an environment that has everything we would require to run the model inference. The first step is to have a GitHub repository with all the code and documentation that we would need to run the demo. In this case, it is the AICOE OCS demo repository. This repository follows best practices of data science workflows. The information on how to create such a project is encoded in the data science workflow repository linked in the description. We also have a project template that we use to create this repository, and you can use this for your own data science projects as well. All right, let's look into the files that are the most important for setting up the environment. The first file is pip file, which is a collection of all the packages that are required for running your notebook and the NLP code. Sometimes we also have to specify the exact version of the package that we're interested in because that is the requirement of the model. Once we have the pip file set, we have to lock it and get the pipfile.log file as well. Once these two files are set, the next thing that we have to look at is the aicoe-ci.yaml file. This file is used to configure the AICOE pipeline. The AICOE pipeline is designed to create a container image whenever a new release is done on this repository. So whenever we create a new release here, the build pipeline will be triggered and the new image will be pushed on the query registry. You can find more information on how to configure this for your repository in the description of the demo. Here we are going to look at the configuration file and look at some of the important parts here. The first thing is the build strategy, which is a Docker file in this case. That means that the AICOE pipeline would look at a Docker file and use that to create the container image. The registry specifies where it will be pushed, and the org specifies the org on the registry. So once we have the AICOE YAML file, we also need to have the Docker file. The Docker file has the base container image that is required, some of the environment variables that will be baked into the container image, some Linux dependencies that are required for the project, and finally it gives instructions to copy some of the source code that we would need in our environment. Alright, we have the repo and the container image set. Next, let's log on to an ODH Jupyter Hub instance deployed in the Operate First cluster. Operate First is a concept of bringing pre-release open source software to a production cloud environment. It has a cluster with an ODH instance deployed. In this case, we will use the Jupyter Hub service to run the model notebooks. So here we are at the spawn page of the Jupyter Hub service. The notebook image selected here is AICoE OS Climate Demo. This image was created by the AICoE CI pipeline when we created a new release of the GitHub repository. Once we have selected the image, we can select the container size and the number of GPUs that we need for this model. When we have selected that, we can click on the Start Server button. Alright, so the environment here is ready and we can see the AI COE OCS demo repository code being copied here. So before we move on to the notebooks and describe them in brief, let's make sure that our S3 connection works, because that is where the input and the output files required to run this demo are. So to connect to S3, we need a credentials.env file that should look something like this: S3 endpoint, S3 bucket, S3 access key, and S3 secret key are the 4 configuration keys that are required for us to connect to S3. Once we have set that, we can look at whether or not we are able to connect to the S3 endpoint, and if we have the input files that are necessary for running the model. So let's give the prefix here, data S3 prefix, and right, so let's print it as well. Great. So here we see that we were able to connect to the S3 endpoint, and we have the extraction directory, we have the info KPI directory, info relevance directory, and PDFs directory. So we have all the directories required for the model to run. That includes the input directories and the output directories. Great, so we have set up the S3, and now we can look at all the notebooks. So the notebook that we are currently on is the text extraction notebook. It is the first step of the pipeline, and we are aiming to extract text from PDFs in this notebook. So in the beginning of this demo, I talked about these PDFs of climate reports by different companies, and the NLP model trying to answer questions based on that. So the first step is to take those PDFs and extract text out of them, and this notebook is doing that. The second important notebook here is info relevance. This notebook takes the extracted text from PDFs and then it finds relevant paragraphs in those texts for the KPI questions. Now these KPI questions are something like, what is the base year for carbon reduction commitment? Or what is the target year for carbon reduction commitment? Or what is the target carbon reduction in percentage? So we are interested in these questions and answers to these questions. So this notebook would take all the extracted texts from PDFs. It would take a pre-trained NLP model, and then based on the input files, it would find the relevant paragraphs for these KPI questions. So once we have answer relevant paragraphs to these KPI questions, we would save the interim output back on S3. And the next notebook, which is the Infer KPI notebook, would take these interim output files and take another NLP model and come up with exact answers from those relevant paragraphs. So we had the raw PDFs, then we had the extracted texts, then we had relevant paragraphs to KPI questions, and then finally in this notebook we have the exact answers from those relevant paragraphs. So right, so this notebook would give us an output CSV with with the KPI questions, PDF, and then the exact answers to those questions. So once we have that, the final notebook in this demo would be the create tables notebook, which would simply take the output from the infer KPI step and then create a SQL table on Trino that we can use for visualization in a dashboard. So these are the 4 important notebooks that we use for running the code. The next part of this workflow is to run these notebooks automatically in a pipeline.
Hello. In this part of the video, I will demonstrate how we can run the above 4 notebooks as a reproducible pipeline using Elira. So in order to arrange your notebooks into a pipeline, or more generally a directed acyclic graph of any kind, you can simply open the Elira pipeline editor from here, and then click and drag the notebooks that you need into the editor, and connect them using the UI like this. So once you've set up your pipeline, it might look something like this. So here, each step will execute as a container of its own. So you can click on the step here, open the panel from here, and then in this section you can configure how many CPU cores, how many GPUs, and how much memory that container would require. You can also set any Python file dependencies for the notebook that will be executed in that step. And you can also set any environment variables that will be needed by the notebook. So for example, here we've added the S3 endpoint as well as the S3 bucket that will be used in the notebook. Finally, you can set the runtime image over here. The runtime image is basically the container image within which this notebook will execute. So right out of the box, Elira provides you some images like pandas, PyTorch, TensorFlow, and so on. But you can also add a custom image to this and use that as the runtime image. And that's exactly what we're going to do. So we'll be using this image that was created using the steps that Shrey described in the previous section. And we'll add this to Elira and use that as like a runtime image. So to do that, we go to the runtime images section over here, click on the plus button, and add a image name as well as the source, and then click on save and close. So once that is done, you can add that image as a runtime image from this dropdown right here. So yeah, you can repeat those steps for each step of the pipeline, and then your pipeline is pretty much all set to run. So one thing that you need to do before you can execute the pipeline is to actually configure the runtime where this pipeline will be submitted to and where it will execute. So to do that, you go to the Runtimes tab over here, click on the plus button, and new Kubeflow Pipelines runtime. So you click on there, and then from here you can give any name to your Kubeflow Pipelines runtime. So let's just give it a demo name. And then here you can give the API endpoint for the Kubeflow pipelines, as well as the credentials for the S3 storage. And yeah, once that is done, you can click Save and Close to add that runtime into your Elira. So we already have that runtime added, so I'm not going to do it again. But yeah, once that runtime is configured, you're all set to execute your pipeline. So to do that, you can click on the Run Pipelines button right here, and then give any name to your pipeline run. Select Kubeflow as the runtime platform, and then select the runtime configuration that we just created in the previous step. So once you hit OK, it will package the pipeline and submit it to Kubeflow, and you can click on the run details to see the execution. So once this pipeline has done executing, it should hopefully look something like this, where you'll be able to see green check marks next to each step of the pipeline, signifying that that step ran successfully. So this means that it took the PDFs on S3, extracted the text data, ran the NLP models, and then saved the results to the Trino table. So you can verify that it actually did do all these steps by checking the output on the S3 bucket. So if we go here and look at the input location on S3, we can see that these are the 10 input files that we gave. And we can also see the intermediate outputs from the infer relevance, as well as the infer KPI steps. And then finally, we can see that the results were added to the S3 location, which is backing the Trino table. So yeah, once the results are uploaded to the Trino table, you can simply go to Superset and add that database as a source. So to do that, you can go to Data and Databases and click on Add Database, and then add the database as a source. So we've already done that here, so I'm not going to repeat the same steps, but this is the data set that where we're storing the results from our pipeline. And yeah, once that database is added as a source, you can go ahead and click on the Charts tab on Superset, and then click on Add New Chart. And from there, you can select the dataset where your results are stored as a source, and then create any chart of your liking. And yeah, once you've created a couple of charts, you can easily throw them onto a dashboard like this and visualize the results from your pipeline. So here we have created a couple of widgets and created a very simple demo dashboard. So here you can select, let's say, some KPI like what is the annual production from coal? And then you can see the results that our NLP models extracted from each of the PDFs, and you can see the distribution across different companies. You can also select some specific company name and then see the results in context of that specific company as well. So yeah, that's pretty much it. So to summarize, in this walkthrough video, we showed how we can use Open Data Hub tools to create this reproducible cloud-native data science environment where you can develop notebooks, and then how you can create a pipeline that takes raw PDFs in S3, parses them, runs the NLP model, and saves the results to a Trino table, and then how you can visualize those results on a Superset dashboard like that. So that was all for this demo. If you have any questions, please feel free to reach out to us. Thank you.